Hi everyone, welcome to the third video on Trig 2D applications. The focus of this video is going to be working with sketches that have unknown values, where before we had constants in our sketches and we had to work out a missing side. Now we're going to work where all the values given are unknown and could be in terms of theta or alpha or x or y. I'm going to use some questions that we used in previous videos and also do some new ones. So let's get going. In the first example, I'm going to look at a question we've done before. The question states 2 points P and Q on opposite sides of F, the foot of a flagpole. P, Q, and F on the same horizontal plane. The angle of elevation of T from P is 25 degrees, and the angle of elevation from Q to T is 32 degrees. The distance between P and Q is 30 meters. Determine the height of the flagpole to the nearest meter. Now, we've already done this question. And what we did is we said we need to break the triangle up into two pieces. We first decided that the shared piece would best be side TP. And with the information given, we decided that let's start by working with TPQ. So what we did is we first worked out angle T so that we could use the sine rule. And so I worked out angle T from the other angles. And then I used the sine rule to work out TP, which you can see here. Then we used the triangle TPF, and we used the sine ratio to calculate the height of TF. Now I'm going to change the question. So let's start by erasing everything on the sketch. The reason I'm erasing everything on the sketch is because I'm going to change the angles. I'm going to change the angle of elevation from T to P to be theta. And I'm going to change the angle of elevation from Q to T to be another variable, which I'm going to make alpha. And the distance between P and Q, instead of 30 meters, I'm going to make x meters. Now the question is still the same. I want to find out the height of TF. However, I'm not going to end with a value for TF, but I'm rather going to end with an expression for TF. So I'm going to use the same process as I used before, except this time I'm going to use variables instead of values. So to start, I'm quickly going to erase all the values from my previous answer so that we've got a structure in which to complete with variables. So let's start working. Now the first step I did is I needed to work with triangle TPQ, and the reason for that is I want to use the sine rule to work out TP. Now, to use the sine rule, I need to know what the size of angle T is. And again, to work out what angle T is, I'm going to need to say 180 minus the other two angles, which are theta and alpha. Now, I'm rather going to write it in this format. Now, think for a second, why would I write it in that format? The reason is because this is potentially a reduction formula. Let's get to the next step. So the next step is I'm going to use the sine rule. Now let's quickly put the angle in from what I had before. The angle was 180 minus theta plus alpha. And my sine rule is going to say TP over sine Q is PQ over sine T. So PQ is X. Sine T, I'm going to need a bit of space for that, is 180 minus theta plus alpha. And I might as well straight away just times by sine of Q, which is going to be sine of alpha. And I know that will be sine of alpha over 1. So let's simplify that a little bit. X times sine alpha over, and let's use our reduction formula, sine of theta plus alpha, because sine of 180 minus an angle is the same as sine of that angle. So this means that this length here is x sine alpha over sine theta plus alpha. Now the final step is to calculate what TF is going to be, and I can use the right angle triangle, TPF. So, like I did last time, I said TF over TP is equal to sine of P. That means that TF will equal to TP, I'm not going to fill that in yet, TP times sine of theta. Now I know what TP is. It's this long thing from before. So TF is going to equal to x sine alpha times sine of theta. The sine of theta comes from my previous line, all over sine of theta plus alpha. So even though the answer to this question looks a little bit complicated, it actually follows the same steps as what you do if you're working with values. So let's look at another example we've already done before. It says from the top of a tall building, AB, the angle of depression to a person on the ground is 75 degrees Celsius at point C. The person walks 20 meters closer to the building to point D, and the angle of depression changes to 78 degrees. How tall is the building? Now, when we did this question before, we divided the sketch into two triangles, one triangle there, the green triangle, and the yellow triangle on the left. Then I used the green triangle to work out the linking side, which was AD, in order to work out how tall the building was. I started out working out angles that were missing using alternate angles. Then I used the sine rule to find out the linking side AD. And finally, I used the right angle triangle to work out what the length of AB was. Now again, I'm going to change the question so that I'm working with variables. So this time, let's say that my distance, we can make P, and let's make my first angle of depression X, and my second angle of depression Y. I'm going to erase all the numbers so that we can fill in our answer just using variables. So I'm removing all the values that I've got so that I can just work with the variables. What else needs to go? That last step. And then let's just clean up our sketch a bit. Now let's update our sketch with the new values. So P is the distance between D and C. X is the angle of depression to point C. And Y is the angle of depression to point D. Now to answer the question, what I did first last time was I worked out the angle between those two, which will be Y minus X. And I worked out angle C, which is going to be alternate angles with X. The reason for doing this is we were working in triangle ADC, and I want to use the sine rule. So AD out of sine C is equal to D out of sine DAC. DC is P. Sine DAC is sine of Y minus X. And sine of C, let's multiply both sides by sine of C, is going to be sine of X out of 1. So that simplifies to P sine X out of sine Y minus X. Now for now, in grade 11, we don't split up an angle, so we'll just keep the sine Y minus X as it is. Let's go on to the next triangle. So I now know my linking side. It's quite a long linking name for a linking side, or long value. So I'm not going to fill it in, but at least I know it, so I'll just tick it off. So ADB will be Y because of alternate angles. Then I'm going to use my sine rule. So sine of ADB is sine of Y. Actually, I'm not using the sine rule. I'm rather using the sine ratio because it's a right angle triangle. Times by AD. Let's just move down a bit. And so a way I can describe AB will be P times sine X times sine Y all over sine Y minus X. So my reason for doing the first two examples is to show you that in the same way as you work with values or constants, you will follow the same structure working with variables. Yes, your final answer looks a little bit more complex, but the method isn't any more complex. Now, the last question is more in the structure of how you'd expect it to be in an exam or in your exercise book. So it says in the diagram, PQ is T, angle PSR is alpha, and angle RPQ is beta. Show that RS is equal to T times cos of alpha plus beta, all over cos of beta times sine of alpha. Now, here's the beautiful thing about these kinds of questions. Even if you get completely stuck, you could always do the second question. So let's actually start by doing the second question. So if I start by doing the second question, RS will equal to, it tells me what T is, it tells me what alpha is, and it tells me what beta is. So all I'm going to do is substitute in. T is 100 times by cos of alpha 12, beta 60, all over cos of beta, cos of 60 degrees, times sine of alpha, sine of 12 degrees. Fortunately, I can use a calculator to work this out. Type the whole lot in, and I get 63,18 meters. So with these questions, don't give up. Often you can do the second part without having done the first part. Now let's go back to the first part. It asks me to show that RS is that. So I want to find out the length of RS. Now with questions that say show that, it doesn't mean that you must use this piece that they've given you. You actually just need to work out the length of RS, and you're expecting your answer to be T times cos alpha plus beta over cos beta minus sine, times sine alpha. And the reason why they're saying show that is so that you can do the second part. So, like normal, I'm going to work out the value of RS. Now let's see what my triangles look like. I've got PQR, which is a right angle triangle, and I know a side and an angle. So I can definitely work out any other angles or sides missing in this. And then I have PSR, which has the side that I want to work out. And then I could use the big shape, but that actually doesn't help me because I don't have enough information in the big triangle. So I'm going to use the yellow triangle first and then the green triangle. So let's just write down what I'm doing clearly. So we're doing question 1, in triangle PQR. Now, in the green triangle, at the moment, there isn't enough information. So I'm going to have to start in the yellow triangle to work out the linking side, which is going to be PR. Now, according to what I have, I know that that side's adjacent and that side's the hypotenuse because I've got a right angle triangle. That's going to be cos. So I can say cos of beta is going to be T over PR. But I actually want to know what PR is, so let's times both sides by PR. PR cos beta is equal to T. Therefore, PR is equal to T over cos beta. So my linking side is T out of cos of beta. So next, I'm going to move on to triangle PRS. Now in PRS, I have an angle alpha, and I have the length of a side, but I'm going to need another piece of information. Now, easiest rule to use would be to use the sine rule. Remember, it's not a right angle triangle, so I can't use the ratios. And the angle I want is angle RPS. So RPS. And I can work out the value of that angle if I use the large triangle. So that will be 180 degrees minus beta 90 and alpha. Let's just give a reason here. Sum of angles in triangle PQS. So that will simplify 180 minus 90 to be 90 minus, and let's keep it in this format so that if I want to use the reduction formula, I can. So that looks pretty good. Now I can use the sine rule. So I'm going to say I want RS out of sine of this angle, 90 minus beta minus alpha, sorry, beta plus alpha. Let's make my line a little longer. It's equal to a side PR out of sine of alpha. That looks good to me. So now RS is going to equal to PR. And if I look carefully, that is a reduction formula. That's going to equal to cos, because when I say 90 minus, it's going to change to a co-ratio, beta plus alpha. So PR times cos beta plus alpha over sine of alpha. I also know what PR is. So let's substitute that in. I'm going to get PR, T is at the top, cos of beta is at the bottom. Oh, this is starting to look like what I want. Times sine of alpha. At the top, cos of beta plus alpha in brackets. And that looks like I'm done. Now let's go back to the original question. I wanted to prove that RS is cos alpha plus beta, beta plus alpha, same thing, over cos of beta times sine of alpha. Exactly, that's what I've got. So when you tackle these questions, don't panic because you have variables. You still tackle it the same way. Break your shape up into triangles. Find the length of the linking side, and then find the length of the side you need. So always work like that. Break it up into triangles, work out what your linking side or angle is, and then work out the piece that you need.